All right. It is time to begin, ladies and gentlemen. Okay. So I don't think I've taken roll yet. Okay, so what is everything that you can tell me so far that you've learned about hydrocarbons? What's the first thing you'd want to start with in any hydrocarbon compound?
There's way too much to learn about.
They contain hydrogen and carbon.
They do contain hydrogen and carbon.
However many carbons there are, there's double plus 2 hydrogens most of the time.
Most of the time, if it's an alkane. I mean, you're not wrong when you say that. Okay? Sometimes it just takes confidence. Okay? It just, exactly. Okay? About what? Oh, okay. I'll put something up here and we'll see how confident you are. Okay? Well, we'll see. Once we, try to take this confidence and move forward.
I'm confident that I will do my best.
Got you.
Am I allowed to use my notes?
No.
Confidence is really key.
1, 2, 3.
I just need to
Okay. So I will hit pause. Or do you not want to do this? We had a student volunteer.
I'll do it.
Well, leave that notebook back there.
Just look at one thing.
You can look at one thing. This is where I'm going to hit pause, and you'll see brand new material up on the board. Okay, so you can see that there's different types of handwriting on here, that which I know what that's supposed to say, but okay. Now, this is new material because how many methyl groups are on there? There's 2 methyl groups. We've only seen it where there is just one. So what you had done is you are doing things right, okay? So keep that in mind, okay? So always look for these positive aspects that we can see. This wasn't meant to be deflating, because if it was, well, then you wouldn't have any of this down. So you're following everything that you said that we should do. The longest continuous chain is 8. It's saturated, so it's an alkane. There's the 8 carbons. Then you put a box around here saying that there is a methyl group, okay? And it's on the 3rd carbon. So if we had this, if I covered this up, this would be 100% correct. But you have 2 methyl groups on there. So what happens then is you still have to try to decide, okay, what direction is this moving? Is it going that way, left to right, or is it going this way, right to left? So what you would do then is go 1, 2, 3, and all the way up to 8. So is there another methyl group on here?
Yeah, question.
Yes.
So if there's the 2 group things on different sides, you would count 1, 2, 3 for the first one. I get that, but would you have to keep going the same way for the second one?
That's correct. But you just don't know what direction you're going to go for sure. Because think of this sport.
Golf.
Why golf? That's right. Okay. So are we going to go left to right? So notice we see derivatives on number 3 and number 6.
Really doesn't matter because they're the same distance either way.
They're the same distance either way. Because if you're going back this direction, 1, 2, and 3, which we have, 4, 5, and 6, That's the only thing that's missing. So what you have down here is not too far from being correct. Okay? But you wouldn't know that because you haven't been taught that yet. Okay? So there's a lot of things that were correct with this. The only thing we need to change, okay? So what numbers were those derivatives located? 3, 6. Okay? Now, what's maybe silly about this is even if they're on the same carbon, okay? I'll mention that in just a moment. And typically when you do these, it's hard to make sure you have enough space. Commas separate numbers. Dashes separate numbers from letters, okay? So 3, 6, those are our two numbers. And then, actually I did have enough room, sorry. Then the only thing we would have to do is, what's a 3-sided figure called? Okay, and then if we had a 4-sided, it's a square, but what might the geometrical name for that be besides a square? Well, true.
Everyone needs a hero. 0 people.
Tet something. You ever heard of a tetrad? Okay. This would mean 4, but we don't get that high at this level. Juniors do in general chemistry. Seniors do with the organic class, but typically we do not get that large in numbers. So if we had 3 of those on there, then we would call that 3, 6, 7 maybe trimethyl octane. But do you want to try to take a guess? What do you suppose maybe only 2 means? Not bi, like a bicycle.
Dose.
Close. Dimethyl, okay? So 3, 6 dash dimethyl, okay? So then the prefix here, you don't have to have a dash in there, okay? So everything that you put beyond this was right. It's just a little more specific once you have 2 of those derivatives on there. Okay. So we have just a little bit of content we want to go over because as you would be aware, just like in your other classes, I would be led to believe we are holding you accountable whether you are here or whether you are not here, whether it's at a golf meet, softball game, or at a track meet. Okay, so this is where we left off with, correct? I remember talking about benzene because it was difficult for you to give me the formula for benzene even though it says it right here. So then this must be where we begin. Okay? So I don't know how much of this you actually have to write down. But
Oh, we did this one.
we did. Okay. So naphthalene, I'm not quite sure what that is other than just 2 fused rings. Maybe it's in the organic book. I will take a peek and see if it is in here, what naphthalene possibly is. I want to say it's like those little packing peanuts maybe that you would have in a box that maybe you had ordered something from maybe Amazon, and that naphthalene is those styrofoam peanuts perhaps. That's what my guess is. So go back to the index, see if naphthalene is in here. And I do not see it in the index. I thought that I had read that before. Maybe if I look in your physical science book, maybe it's in here. So keep in mind, a lot of the content that we see is in chapter 23. that begins on page 705, 706. Okay, so a lot of the same concepts that we're talking about, you can find in here, you can use as a resource then as well. Naphthalene used in mothballs is a fused ring system. So it was in this book, okay? So had the size right, just the use of it not correct, okay? So for instance, a week ago today, okay? Myself was not in here. You were perhaps watching myself up there on the board because Mr. Paulson was in here, correct? And what title would you give Mr. Paulson? Google. We looking at our phone for something? What? So good thing you know that now in this classroom. It's not a distraction at all. So that doesn't answer the question. What about Mr. Paulson? What would you consider him? A substitute, which means a substitute teacher is someone who comes in and replaces your regular classroom teacher. Okay? So what this means then, as far as substituted hydrocarbons, I don't know if that shows up on your video. I found that out in the A&P class. Oh, yeah, you can see that, probably because it's got a darker background, okay? So what can happen is if hydrogen is not located on a compound, it could possibly be substituted by other, whether it's a halogen or an oxygen, substituted hydrocarbons. It's possible to change hydrocarbons into other compounds, okay? So I want to do this one, and then that's where we'll stop at the end of this slide here. And we've talked about these, okay? Can anyone give me an example of a compound that has a double bond? And if I just tell you, you're going to hit yourself over the head and say, I knew that. No. No. No, that's an inorganic compound. I mean, you're trying. We do appreciate that. It's not like we're sitting here saying, duh. I mean, you are giving answers, so that means you are thinking. No. It means it's a compound with a double bond in it. Nope. Water, ammonium, those are inorganic compounds. The clue would be, we said something that we cannot live without. Plastic. Plastic is known as polyethylene. So why would that be significant with that term right there when we say ethylene? It does. You're not wrong, but can you be more specific with that? It's in the bonding. Because what is ethane? You went the wrong way. Single bonded. Ethane is single bonded. Okay? Because what's the suffix in ethane? A-N-E. That means single bonded. It's saturated. If it is a double bonded compound, just like polyethylene is, what's the suffix? E-N-E. So anytime you see a compound ending in E-N-E, that's telling you you have a double bond located somewhere. So then, what might be an example of a triple bond we have talked about in class? And it is a common name. And you are the one that answered that. Say that again? Not ammonium. That's an inorganic compound. It's in the shop. Although that is hydrocarbons, you're not wrong, but nope, not diesel. You might use it to cut things, not a plasma cutter.
Thermite.
Metal.
Yeah, you're cutting metal, yes.
Oh, well, no.
It's a type of torch.
Propane.
I don't know. Dilly.
Okay? So this was ethene. Okay? So the suffix for an alkene is ene. So that tells you that there is a double bond located somewhere. And if you have a whole bunch of these linked together, it's called polyethylene or plastic. So in this case, it's called ethyne. That's the scientific name. But people will combine, or shop, or industrialists will combine this gas with oxygen.
I don't even know. When did I say that?
I thought you had said acetylene.
Maybe I did.
Okay, an acetylene cutting torch. That means it's ethyne, the scientific name, but the common name is called acetylene. You combine that with oxygen, and that really increases the temperature to maybe over 1,000 degrees. You can cut metal really, really easily because it is so hot. Okay, so let's see here. That's what we're going to start with next week as far as talking about these. But as far as today is concerned, come on. Okay. We can erase all of this. Erase this nice handwriting. Okay, so let's see here. That's already purple. We'll try this. What would happen if I put a double bond? Well, first of all, what do we have right now? Why are you right?
Because it has 4 carbons.
Has 4 carbons. There is your prefix. And what's the suffix for a hydrocarbon that is saturated?
Or whatever it's called. It's
This means a saturated hydrocarbon known as an alkane. That's 4 carbons in length. Okay? So the moment that you see this, okay, we got to make some changes between these first 2 carbons. Because what column is carbon in? No. Okay? So what that means is how many bonds does carbon want if it's in the 4th column? Okay? It only wants 4 bonds. It can only have 4 bonds. So what's the problem between these 2 carbons right now? It's got 5. Carbon cannot do that. Cannot make 5 bonds because it can only have how many?
4. So then how many am I?
Okay? So what happens is, did a lot of you write down the formulas for an alkene?
I don't know. I wrote down stuff yesterday.
I wrote down 8.
Remember, this was CnH to the 2n plus 2.
Yeah,
But alkenes, okay? So what would we put in for N on this compound?
1,
No.
2,
No.
4, 5.
5.
No.
1.
No.
Could it be negative?
How many carbons do you see? 4. How many carbons do you see up here? Okay. Then how many hydrogens should be in this compound? If you put 4 in for N.
Should be 10, but there's 11. No, 8.
Why is 8 correct?
Never mind.
If you put N in for 4, what are you doing with these two numbers? So what is 2 times 4? Okay, 8. All right, so that means this hydrocarbon can only have 8 hydrogens. So we got to get rid of 2 of them. What 2 do you think we would get rid of? Because remember, you can only have 4 bonds. I had 5, but I meant to say 4. Okay? The and is a good answer. Because you correctly said this carbon's got 5 bonds. 1, 2, 3, 4, 5. It can't do that. So we will take this one. This carbon now has 4 bonds. How many bonds does this carbon have? 1, 2, 3, 4, 5. It can't do that. So, okay, there we go. You said that we needed 8 hydrogens. Let's count them. 3, 5, 6, and 2 more is what? 8. So that's got to be right. So now, how does the suffix change from a saturated alkane to a multiple bonded compound? We've said it today. Okay? Because what did we say this compound is called? Poly something if it's plastic. Polyethylene. So ethene or ethylene means you've got a double bond. So what is the suffix in a double bonded compound? When we say ethene. Ene. That's right. So we know the suffix is ene. Okay? Because our organic family has changed. Because it's not an alkane anymore, it is an what? It's an alkene. So how many carbons are in this alkene? What's the prefix for that? Okay? Now, what happens is you can do this. That double bond is located after which carbon?
1.
You can do this, but it's not necessary. The reason I say that is, how do you write the formula for hydrogen chloride or hydrochloric acid? It means the same thing. Okay? So this is hydrogen chloride or hydrochloric acid. You're not wrong if you do this. You would just look silly. Okay? If you're going to go off to college, okay, and you do this, and the professor says, "Where did you go to high school?" Don't say Coleman-Egan. Okay? You can do this and just say you went to Chester or Flandreau or Madison or something like that. Don't say Coleman-Egan, because then that's going to reflect upon us as a school. My point is, do you need those ones?
But what
It's-
if you were right?
What if we're right about what?
Like, if you did something smart.
Is that smart?
No, not.
Oh, something other than this. Well, then, sure. Then you can say you went to
What if
Coleman-Egan.
you didn't know if it was smart?
Well, that's just a gamble you're going to have to take. You would know that.
Don't lie to your professors.
What do you think is going to be better? Say, "Wow, where did you go to high school?" Or, "Where did you go to high school?" Which one sounds good? Which one sounds bad?
Wow.
Okay? All right. So, again, you're not wrong. It just looks silly. So we apply that same logic. You're not wrong, but you can also just do this. It's just understood that that double bond is located after the first carbon. Okay? This is a lot more acceptable than what this is. Okay? We'll explain why in just a moment. Do we understand why this is called butene? Because what is this telling you?
It doesn't have, it's missing hydrogens.
Well, it is, but that's not a good way of explaining that. There's a double bond somewhere. Okay? Then what is this telling you? That there's 4 carbons. Then what do you suppose this is telling you? There's a double bond located somewhere. Do we understand that? Front row. Second row. Third row. So a lot of you are nodding your head, yes, I've seen this. If you don't understand this, you are not doing yourself any favor. It's just going to get more difficult. That's just the way that it is. Because I think you'd agree it's going to happen that way, that it's always going to get more difficult. Okay. So, now we're really going to throw you for a loop. Okay? So, pick a number between 3 and 7. 5 is the first one I heard. Okay? Okay? What geometrical shape is that? It's a pentagon. So what this means is every intersection here, these 2 lines are intersecting. There's a carbon atom. These 2 lines are intersecting. There's a carbon atom. Okay? Now, you don't have to have these written perfect when you are drawing out geometrical shapes. Okay? Although, just don't be sloppy like that. Okay? And when you're drawing geometrical shapes, it usually works out better the larger you write them. But that doesn't mean you do that. Okay? You're not doing yourself any favors that way either. Okay? Okay.
So those angles are at a 72 degree. Those are awesome.
Okay.
Oh my God, Tom.
What do you suppose these dashes are? Those are hydrogen atoms. Okay? So, what is, you said a 5-sided figure is called a pentagon. Okay? So, what about this here? What is this compound called? Pentane. Okay? So, we have 5 carbons here. We've got 5 carbons here. So, you call this pentane. But there's no way you would know this, but how do you suppose we've got to keep them 2 compounds separate? Yeah. Yes, we do. So anytime you're dealing with what's called a ring structure, this is a ring structure. 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 Then this one gets to be a little more tricky. One, two, three, four, 5, 6, shoot. I didn't do that right. Because these are tough to do. Okay, so there's one. 1, 2, 3, 4, 5, 6, 7. So that's got 7 sides. Anytime you're drawing a geometrical shape, that is a ring structure. Okay? which goes back to this. If this is pentane, a straight ring structure, we need to be able to tell the difference between pentane and whatever this is called. Any ring structure means it's got this prefix, cyclopentane. Cyclo means ring structure.
So it's an isomer?
Close. You can answer your own question here, okay? Because the formula for this, you have 5 carbons in each case, right? Right?
Yes.
So how many hydrogens does pentane have?
12.
You just saw it because I wrote that down.
Yeah.
Okay, what's 5 times 2? Then count your ends. There's 12. So when you look at a ring structure, we'll just say that this one's number 1. What is 5? And how many do these how many hydrogens are on each carbon?
2.
Okay? Which leaves you a total of C5H what? So these are not isomers of one another. They can't be. That's why you can't put them together, is right. Okay?
Is there a way you can put a long one with a ring?
A long one with a ring.
The long, oh? Okay, so you know how the isomers, you can put them together?
What if you just kept it?
You can, but we don't want to go in that far in depth. The reason I say that is you can, because this is a little further in depth thinking. Okay? That's ethane, right? C2H6. Okay? That wasn't a very good example. This is what I meant to do. That's C3H6, correct?
Yep.
Okay. This up here is also C3H6. Okay? Because how many carbons are in this structure? How many carbons are in this structure? Okay? How many hydrogens are in this structure? Okay? Do we see a similarity here?
Yes.
Okay? These have the same formulas, don't they? But what's the difference between this compound and this one? One's a ring structure. Ring structures can be alkanes, and they are. So even though they have the same formula, these are isomers of one another. That answers your question, but I don't know if you want to go that far in depth. This is more so of a senior level application. So hopefully asked and answered. Okay. Front row. Now, for you individuals who are gone, it is vital that you stay on top of this. We are holding you accountable for this. Yes?
So if there's a way you can like put it on the bond thing on the like a straight one, is there a way you can do that for the instructions?
You can. Let's not do that at this level. That is definitely a senior level application. It's a good question. Don't think, oh God, we said we're not going to do this. No, that's an excellent question, but we're just not going to do that. Okay, right now. Okay. Any questions on this? Okay. So, let's go back to how we started the class. Is anything here still the same? Yes. Okay? But what is different from what we had earlier? This is pentane. But now we've got 2 more carbons on there. Okay? So find your longest continuous chain. 5. Is it saturated? Yes. So it's an alkene. Is there anything branching off of that parent chain? Yes. Where are they located?
Number 2.
Okay? So this is called a what group? Okay? So what number of carbons in the parent chain is that methyl group located? Okay? Is this the only methyl group on there? No. Where's the other methyl group located? Now, this is where you think it's, what does redundant mean?
Dumb.
No.
Not, you don't recommend it.
No, I wouldn't say that either.
It's
Say that again. You're just saying the same thing. That's what we call insanity. Because you're doing the same thing but expecting a different outcome. That's what insanity is. But in this case, being redundant, even though these methyl groups are located on this second carbon, you still have to write both numbers on there. Okay? Well, you don't have to, but you're not correct if you don't. So 2, comma 2, okay, dash, what does 2 methyl groups mean? Die. Then how do we finish this? Pentane. Okay?
This is why we can't wear hats in school most of the
Why we can't have nice things. I'm sorry.
You say that, but do you really mean it, though?
Yeah.
Oh, yeah. Does the rest of your classmates agree with that?
No.
So what does that tell you then? I guess I'm sorry, I fail to see the humor in that. Okay?
Tell me that they're haters.
So we're haters, huh? Okay. Okay. Maybe that should be our assignment for Monday.
Oh, thank you. Maybe that one, but not me.
Why not? Seems to be a joke in here. Yeah, is this, what does it mean to be a broken record? Does that mean it happens once? It keeps repeating itself. So what does that tell you then?
He's repeating his dumb actions. Or something like that.
Okay? We should be able to name this, at least the parent chain.
1, 2, 3,
What is 6?
4, 5, 6. C.
Can we be a little more specific?
No. It's cyclo.
Oh, yeah.
Can we be a little more specific?
Wait, hold on. Would the number be like the CH3 and then CH3? It's a methyl, so where's 1 at?
Wherever you think the lowest combination will do. The most common place to put these is like on a clock. Usually we say 12 o'clock. But if you do that, make that number 1, okay? What happens if you go counterclockwise? Where is your first derivative?
Don't even know what a difference is.
4.
This is a derivative. That is a derivative because they are derived from methane.
Okay, so you would go to the right because it's closer. Or you would go clockwise.
Okay? But that doesn't answer the question of answering where number 1 is. You can put number 1 anywhere on here. You can make this one number 1 or this one number 1. Why would you not pick this one as number 1?
Because that's not how the clock works.
If you do this, this methyl group is located on which carbon? And then this one's on what? Is there a lower combination than 2 and 4?
Yeah. 1 and 3.
Dimethyl cycle. I just ran out of room. Okay? So then the last thing, very quickly, we'll keep this simple. This is a substitution. Okay? What is the parent chain called? Propane. Is there anything branching off of that propane?
No.
Yes.
Oh, yeah.
There's a chloral group on there. And which carbon is it branching off of?
2.
So 2 dash. Okay, so what this does, this tells you have an alkane. Everything's saturated. This tells you have 3 carbons. This tells you you have a substitution of a halogen derivative. And this one tells you where it's at. Okay, 41 minutes, that's plenty long. We will continue with this. You have your first assignment next week. We're holding you accountable. Again, I can't say that enough. Dinner is the first shift today.
Oh, yeah, we're eating.
So we'll catch up to you next time.